who is from Cameroon. Okay, congratulations on the selection of Colombia. 53%, and this is a great news because he's my friend. He's the only president, he's the second president elected at the age of 92 with third life. And I think I wish that your country progress under this age-old wisdom. Okay. I was very, very excited when I heard about constitutional code. I was looking into life. But Palvia is my personal favorite. What happened was a long, long time ago, one of my friends from Cameroon, back in I think it was like in the 80s, someone sent me a picture of his office. He was sitting in the office, and behind his desk, there was a picture of Palvia. Okay. And then recently I had an online meeting with a lady, Babalola, Professor Dr. Babalola, and she is also the Vice President class for Africa, and she was online, and behind that was a picture of Palvia. Okay. So he is a constant factor as my personal favorite. You voted for it?
No.
Okay. But I mean, I follow Cameroon, I follow Nigeria, I follow Yemen. I do a lot of. I try to understand the politics of Africa to some extent. You read about it? आप लोग पढ़ते about the world? Let me ask you a question. Where is Comoros Island? If you answer this question, you get 500 rupees. This is an OIC country, Muslim country. It's called Jazair al-Qamar. Yeah. Jazair al-Qamar. If you give me the answer of this today, you get 500. Tomorrow, 50 rupees. Day after tomorrow, not for you. Okay, for you, I ask you a question. Shall I ask you a question? Give the 5 names of the Muslim state in Russia. 5 Muslim states in Russia. You have to give me 5 Egyptian pounds. Okay, Nigerians. Why you decided to change Buhari? He was my personal favorite. Who's Nigerian? He was doing well, you know.
Well, he's not a part of us.
Who's Ugandan? No Ugandan? Okay. Anyway, thank you very much. Delighted to be here. And remember, when I was young, I used to read about Yemen, the South Yemen, and North Yemen. All of a sudden, Yemenis decided to unite together to make a Yemen. And they decided to fight and separate it. I think it was the Southern. No, we're still sitting together.
They're not together.
You know, I have this craze of reading about the world. When I was very young, I used to read lots of travelogues about how people travel from one place to the other. So I actually know a little bit about it. Okay, but I'm sure that Yemenis are good in many things, and certainly Egyptians. Okay, why you decided to have a democratic government and then change it to again a military rule?
Egypt from thousands of years under the Latin.
So it's habitual.
This is not better. Also, that I hear you now. The situation in Egypt is different because the military is part of the people country. So it's the same. Mahmoud was in the military.
May be aware that people are hearing about Egyptian comments. So I want to hear your comments also. This was just to set you to learning, because remember that learning is holistic. You learn more by learning about everything, and you need to know about world. You need to know. Okay, so this is what we have discussed. Yesterday we were discussing about a very interesting experiment which is called inversion recovery, and there was an elegant, classical, wonderful example of two-pulse sequence. And today we will move forward. If you have any question about this, yes.
This one.
It's not a pulse sequence, it's frequency spectrum.
One. Was only that.
Big T1.
Yes. All of this on that one.
Yes. Okay, so let me explain. It's supposed to be zero also, zero delay, and then you record. These are various experiments, separate experiments. Each one of them has a different delay, right? And then you go all the way to from minus that to plus that. Okay, so from minus that to plus that is relaxation time. And remember, relaxation time, as we have discussed, it different for different nuclei. So if you have 5, 6, 7 protons, the relaxation time for each proton is going to be different because they have different number frequencies, different electronic environment, and that you can see here. Relaxation time for, let's say, methyl is 3.3, something 3.7, another method 3.2, 3.2, 5, 4.8, something like this. Okay. So T1 is among the relaxation processes. There are many relaxation ways. When you excite a system, the system loses energy by various ways. It's not one way. Various ways, lot of ways, but two are predominant. T1, big T1, and big T2. Among them, T1 is about 63% of the energy is lost by T1 process. So it is a prominent relaxation process it's called longitudinal relaxation because it takes the entire magnetization vector from many phase to up, right, to the thermal equilibrium. While T2 is actually not a relaxation process. It's just like if you have 3 spins and you have, let's say in terms of energy, you have 3 balls, you have 2 balls, you have 1 ball. You just exchange the balls, right? between the spins. But at the end of the day, the number of balls would remain the same with these three groups. So energy would not really be lost. So T1 is the actual most important relaxation process which we try to measure. Okay. T2 is a process which is just D phase. It's D phase, and I'll tell you what D phase is. Yes.
What the majority of the T1. They say what the prefix to each of the T1. We have small molecules, different amounts of big molecules, and
Someone else here. The question has to be
what the benefit to measure that this T1 or what the application. Some literature is talking about the small molecules and big molecules like proteins.
okay. So yesterday there was a question asked about what are the factors affecting T1. And I said that the most important factor which affects T1, there are of course many factors which affect T1. But the most important factor is molecular motion, tumbling. Because remember that your molecule has absorbed energy, and that energy has to be transferred to environment, lettuce. Okay, and that energy would be most effectively transferred when molecule is tumbling, is moving. Because remember that energy can only be transferred when frequencies matches, right? So if molecular motion is appropriate, the energy would be transferred. If it is too fast, very difficult. If it is too slow, very difficult also. So depending on the motion, now motion will depend. Molecular motion in solution will depend on viscosity of sample, temperature of sample. Okay, so the more temperature, more motion. Less viscous, more motion. Okay, so small molecule, more motion. Large molecule, slow motion. Okay, so it's so logical. It's so logical for you to understand.
Why the small molecule five for the T1 for the small?
Because small molecules sometimes move very fast. When the molecular, I said molecular motion is too fast. No. Molecular, if small, remember that if molecular motion is too fast, it's difficult to transfer because it doesn't match, right? If it is too slow, it's also difficult to transfer. When it matches somewhere in between, then it's most effective to transfer the energy. But you don't need to worry about that. Just remember that T1 is the predominant mechanism for transfer of energy. Okay, and this is about 63% of energy is lost. 63% of the energy is lost through T1, big T1. There are a lot of T's in NMR spectroscopy. You will see about T1 small, but this is big T1. Okay, it's called spin lattice relaxation. Okay, now we move forward to another 2-pulse experiment. And now you will tell me what this means. Okay. Open your mind. Start imagining. Don't be afraid to be wrong. Curiosity is the mother of knowledge. Be curious. Okay. Be curious. Try to respond. Ask questions. The elegance of a person's mind is measured by the question, not by answer. You understand? And this is Elizabeth Crew, very famous philosopher who said that. Okay, so 90 experts on your notebooks. 90 experts. Where the M0 will go? No, expect plane, of course. Where? Why? Delay. What will happen to that? Think of it. Yeah, delay. Just something. Not full delay. Not full T. Just some delay. What will happen? If it is a big T, if delay is too much, then it goes up, right? This is small delay. A very small delay. Close to zero. What will happen?
Another advance from
All three of you. Yeah, you are three. Okay.
I think that would be small.
No. Come. Okay. They were up, right? I cannot bring them up. 90 expulse. This is X5 plane. This is Y, and all three spins. First, second, and third at the same place. Okay? Phased, coherent. They are coherent. You know what I mean? They are just at the right place. Together, all of them. As I give you the next example, that if you have a tractor and if you hit them by a pulse, they will all fall down on the earth, right? Okay, so they are together. After some delay in rotating frame of reference, right? Rotating frame of reference, they have a differential frequency because these are three different spins, right? So, yeah. Okay. They split, dephasing, right? More the time, more dephasing. More the time, more dephasing. So from coherent signal to decoherent signal. The spins can sit. Sorry, we can all sit. Now,
the A of this time will give us chance to shape between.
absolutely, it's called chemistry, but here we're talking about something very, very different. Here we're talking about magnetic inhomogeneity. Magnets, despite the fact that magnets are superconducting, super stable, very, very expensive, they are still not 100% homogeneous. They still have imperfection. They still have minor difference. The magnet, the entire magnet in which you place your sample, will not really have every region of your NMR tube will experience the same magnetic field. They're going to be slightly different chemical shape. Slightly, even if it is minuscule, even it is very, very small, the other will receive multiple magnetic fields. right? Multiple magnetic field. Adil as a molecule in this tube, the upper part of several others will receive different magnetic field. So this imperfection in magnetic field will make Adil. What will happen if magnetic field is slightly different? For the same Adil,
different piece.
Some of them is fast, so looks of
let's say if you have ethanol molecule, and ethanol is filling your 5 mm tube, and the magnetic field for all the ethanol from top to bottom is same. Oh, because magnetic field is not perfect. There is no magnet design in the world and would never be designed in the world who is 100% homogeneous. They still would have some kind of an imperfection. You know, like 500.00001 or 499.99999 slight difference in magnetic field. This slight difference in magnetic field will affect ethanol, CH3, CH2OH. If there is a slight difference in magnetic field, magnetic in homogeneity, what will happen to Larmor frequency? Wonderful, excellent. So the Larmor frequency of the same proton would be different, slightly different. And that is a bad thing. You don't want to do that, you know. You don't want to see CH3 of ethanol having broad or different signals because of magnetic homogeneity, right? So how would you correct it? You understand the problem? The problem is that you have every sample which you prepare, you will have solution of that sample. Okay? And that sample is, let's say, about 5 mm. This is almost quarter of the tube is filled with that. Right? So, and then around this is a magnet. And that magnet is 100% homogeneous. Then there is no issue. Right? But this magnet, in reality, in real life, is inhomogeneous. It has imperfection. Though this imperfection is less and less in modern NMR, but still the molecule fill in NMR tube would feel different magnetic field, slightly different magnetic field. Because of magnetic field in homogeneity, it has nothing to do with chemical shapes. It has nothing to do with coupling. It is just instrumental problem. You understand? Instrumental problem that this magnetic field would have 500.0001 megahertz, or somewhere is 499.99995. This slight changes in magnetic field will cause what? Remember that magnetic field is directly proportional to Larmor frequency. It means that Larmor frequency of the same proton will be slightly different because they are experiencing inhomogeneous magnetic field. And as a result of it, they would start non-coherent. You know, they become dephase. They start dephasing. You know, they instead of one, they would start like splitting into for nothing. It's not required. You don't want to do that. This is a problem which NMR spectroscopists have to face, right? What would you do to rephase them? Because the NMR experiments are often run for 1 hour, 2 hours, 3 hours, one experiment. There are so many pulses you need to give. what you must have is this one proton, one specific type of proton, exactly at one position, not as a fan out, okay, not dephased or distorted or destroyed, not because of magnetic inhomogeneity.
Another one.
Shabash. You know what shabash means?
Wait,
No shabash Sharif.
say Shabbat.
Huh?
Say Shabbat. Today you
You
are
should-
talking more about the politics.
Talking about more politics. Okay. So you give a 180 pulse. What would happen 180 pulse? And then wait for the stiff delay again before turning on the detector. Isn't it exciting? Right? So exciting. You rephase, you correct the imperfection caused by magnetic inhomogeneity by giving a 180 pulse. It's not a magic, I'll tell you what it is. Okay. And then you record FID. This is the language of NMR spectroscopy. NMR spectroscopy is written like this. Experiments are written. They don't write you a paragraph. They write this. They write delay. They write again a pulse, width of the bar, tell you 180 or 90. This is 90, this is 180, this delay, and this opening the detector FID, right? What will happen? This is, if you understand that, it's such a blessing on all of you. Okay. 90 bars. Okay. Delay. Splitting. Not because of chemical shift. Because of magnetic inhomogeneity. Right? Now you give a 180 pulse.
How
180 X pulse. Right? 180 X pulse, where it goes? Now, try to understand. The same proton, CH3, forget, now need to forget a few things. Forget chemical shift right now. Forget coupling constant right now. Forget going up right now. Just concentrate on magnetic inhomogeneity. Because of magnetic inhomogeneity, the same metal, let's assume, is split into two. One is getting a little bit more magnetic field, the other one is getting like this magnetic field. It means the one which is getting more magnetic field would have a more frequency, higher frequency, angular velocity, power frequency. The one who's getting slightly less magnetic field is this one. One is lagging behind, the other is moving forward. You don't want that, you want this to be always safe at one place. You give 180 pulse, okay, this goes here, right? Now, after 180 pulse, what will happen? Lagging behind, moving forward, will rephase, merge again, right? Merge again. And when you merge again, you rephase. You correct magnetic inhomogeneity. It's called spin echo. Echo, what echo means? That you hear your voice again, right? Same thing. Your voice is again echoed. It's called spin echo experiment. And it is extremely important because this you need to build it into every NMR experiment, because if you are running an NMR experiment for a few hours, for 30 minutes or 40 minutes, you have this problem, not 30 minutes, but few minutes, then you have this problem of dephasing because of magnetic homogeneity. So this experiment is developed to understand, to rephase that, and to correct the problem. It's just if you have, if you need to run an experiment for about, let's say, 10 minutes, okay, or 5 minutes or something. In 5 minutes, the magnetic homogeneity will split the signals. And every time you correct it. So you built in the spin. Okay? You built in the spin eco experiment, and that is the most beautiful thing. X, Elaine, 180 spinning. You can do it as many times as you wish, and this dephasing, rephasing, dephasing, rephasing. Just 180, rephasing. It means that now you can prepare your vector for other things. So this is, yeah.
What the, you say apply the base 9x. Okay. What the 100? So put the same x 100x or 100y. And there is the same with me. If I take the second pulse 180 on the same axis, it means 100x.
Yeah, that's a good
100y.
As a question, as a good question, I think if he's saying that if I give 180 Y pulse from here, if I give a 180 Y pulse from here, what will happen? A switch, right? Right hand thumb rule, right? And the same thing can be echoed here. They can be combined at 5. So depending on your choice of magnetic field, pulse angle, you can echo that anywhere. Now, let me repeat it a bit more, that it is an excellent method for rephasing due to magnetic inhomogeneity. It is also an excellent method to measure T2. Because what is T2? Spin is peak energy. Okay. I have a video conferencing. You have a T. I will deliver my lectures in China for a few minutes. I'll come back. Okay. आपको चाहिए.
He is ready for
अब में से कौन सक्कर पहुंच गया था? Who went to Sakkar?
Adil.
Adil went to Sakkar.
Yeah.
Where if you give the answer without googling, where is Comrade Saleh? COMROS. Okay, where is Surina? Okay, where is Ghana? Guyana.
Ghana.
Africans. Where is Guyana? You are African.
Yes.
Yeah. You're saying, okay. Where is Guyana?
West.
Okay, minus 500, you have to give 500 fees. Sure. I have to earn money from somewhere to get. Remember that I have to get money for a ticket to Islamabad as well. So, okay. Okay. What are the two major languages spoken in Cameroon? Mention English. And what is the common language of Nigeria?
English.
How many languages, local languages, are spoken in Nigeria?
More than 250.
I think about 250.
How about one time I saw you meeting and you know the earth map behind you.
Islamic
I see only one country is Islamic in the American. What's the strange there? Right?
In South America?
Yeah. Only
In
one
South America, there are two countries, Suriname and Guyana. The two Muslim countries, Suriname and Guyana. Two OIC member states, not necessarily. It's not faith-based. Okay. वो set हो गया? My lecture, my speech. We have a program in Ningbo, China, where we have many people taking course on aerospace pilots. Understand? Ready? Okay.
दोबारा कराएंगे। हाँ तो करेंगे फाइल फाइल को फाइल को ऑलरेडी अभी अभी तो लगेगा हमने तो तुम्हें एक हफ्ता पहले रजिस्ट्रेशन बंद कर दी तो वो अभी तो नहीं। हाँ तो इसीलिए बंद होगी उसकी रजिस्ट्रेशन आ गई थी तो हमने पहले ही बंद कर दी एक हफ्ता पहले। जी नहीं अगले कितने भी कर रहे हैं डॉक्टर दोनों से करते हैं डायरेक्ट फायदा नहीं है चलेंगे। हाँ क्योंकि यहाँ पे सिर्फ जगह 60% सिर्फ 60 लोगों की 60 लोगों की जगह है बस तो रजिस्ट्रेशन। जी यही तो मैं आपको समझा रहा हूँ। नहीं पहले इनको देखिए कुछ हो सकता है इसमें कड़ियाँ लोग या फिर इनको देखेंगे क्या करेंगे अभी। ठीक है ठीक है चलो मैं आपको इन्फॉर्म कर दूँ जैसे ही आएगा ना। चलिए यार माइक चार्जेबल है 5% केबल बना वापस रिचार्ज करना है रिचार्ज ठीक है। हाँ बड़ा हो रहा है तो जब तक देखना पर्दा ऊपर एक्सरसाइज मतलब दो एक
नहीं वो ऐसा है ना कि हम लोग फेस बनते हैं हाँ वो फेस वो बार बार रूटीन कटिंग करेगी लौटना पड़ेगा और एक बार और एक बार में एक साथ खाना भी पहली बार ही है ना तो फेस बंद होता है तो उसमें सारी कंसंट्रेट होता है बस आई वन को क्लिक करने का टाइम नहीं लगता तो उसमें होता है कि आपने एक करनी है आप दूसरों की करें नॉट लाइक वो तीन बार बात नहीं आई तो इस बार है ना ये एक दो बारी बंदा बस स्टॉप करें फिर लॉन्च करें उसका टाइम लग जाए तो साइड पे नजर आ रहा है साइड से नजर ही नहीं आ रहा है वो पे नजर नहीं आएंगे जिससे आप आगे नहीं कर रहे एक बार में ये साथ में कटी आ जाती है जो आप चेक करना चाहते हैं ये करना है साथ में बंदा को बड़ा बंदा का लॉन्च कर पापा का बंदे के नहीं तो एक कंपनी की कोई बंदा बंदे की खुद से खरीदने के होता है तो हम काउंट करें तो टोटल ये कितने से जाते हैं उसके बाद में ये दोनों और एक के बाद
Alaikum, everyone. Sorry, I was the connection. If mother was there, I would see him. Okay. There's so many things going on. There is one event in Bakurere on resilient agriculture in Uganda. I think you should all visit comstech website and try to find something interesting for yourself. And you can benefit from that. Different places, learn and all that. Okay, so everyone, this is a very neat experience. Now you'll ask me why, how come on the face of the earth bother spending an hour of spinning code? What is the use of it? You know, the use of it is that kindly remember that in NMR experiments, you don't want imperfection in the place of magnetic field. If it is not there where you're supposed to have, everything is wrong. Your pulses are wrong, everything is wrong. So you want to make sure that any inaccuracy because of incident is corrected by spinning-code. And that is the reason that the spinning-code is built in all NMR experiments. Whatever you would study from that point on, till you just keep reading it, somewhere in the first sequence, spinning-code is mentioned. Because NMR spectroscopists who designed NMR experiment, they want to make sure that the spin which they are playing with, they are playing with the spins, right? Is there coherent, phased, not dephased, not imperfect, separate because of magnetic and homogeneity. Okay, so this is the reason spinning is important, but also it is important to demonstrate how pulse sequences are important. You know, so we are actually taking you to multiple pulse sequences, maybe 3, 4, 5. And you believe me, there are pulse sequences with 1,000 pulses. Thousands of pulses in one experiment. Okay, so but everything becomes so easy when you predict, when you can play this mental gymnastic in your brain. If you can play with it, and if you can think, okay, 90x pulse will bring my magnetization vector here. If there is any accuracy because of magnetic and homogeneity, I'll just do a spinning code. That would correct me. Okay. and then I do 180 pulse or 90 pulse or 40 pulse or whatever you want to do that, where it will go. So clarity of mind is important, but also it demonstrates that it's so predictable. NMR is predictable if you know the trick, if you know where it will go. Okay, moving forward. This is Spinico, which is the actual mechanism for, which is the most important mechanism of relaxation? T1, absolutely. Thank you.
So I have
You have a question? Sure.
for the last slide. Yes. For sorry for 100 degree.
100, 180.
180.
Yeah, 180 pulse.
180 volts. What makes it the two different? Two pulse was the same.
Where is my three-dimensional coordinate which Dr. Hina has built? Okay. $90 pounds? Yeah. D phase because of magnetic efficiency. D phase because slightly different Larmor frequency. One is slower, one is faster. Rotating frame of reference is slower, will lag behind, and faster will move forward. Like two trains, one with 101, the other is 100. The train of 100, same direction. The train moving with slightly different speed, we actually see because you're in one of the trains, that one train is going behind. Actually, and the other is moving forward. This is what that trains are. Lagging behind and moving forward, right? When you give a 180 pulse, okay, 180 pulse, right? 180 pulse, absolutely. So this goes here, and this goes here, mirror image, right? Now, lagging behind will lag behind. Going slow. Moving forward will move forward. And will merge. Understand? It's echo. Right? You created that signal again. You corrected the magnetic homogeneity. So you have solved the problem. Okay? And you can do it as many times as you wish till it is on the X5 plane. Because remember that the relaxation is going on, it eventually is actually moving away from X5 plane. Yes, sir.
This to Spain to they much together and make this people. Maybe they can do that.
Yeah, it could be 4,
Okay.
5, 10, 20, 30.
But
Our just all merge.
what is the position of our detector? Detect that.
Detector remain, you always think that it is on Y. Okay? Detector, you don't want to move the detector because you would be then confused. Okay? Don't move the detector. The life will be very difficult for you. Right? Yes.
Usually,
NMR would be something like 100 classes.
we
Even after, I am happy. I don't worry about
And we
that.
also decided to make.
Every week we will have samosa party. We will increase our weight and knowledge together. Okay. And by the end of this course, if a weight is 10 kg more and more knowledge, it's okay. This is what we do.
Why we decided to end this for a class early? November.
Yeah. You saying why you want to why you decided to end this class early? You know, there is always end. Life is end.
But the importance to be.
I am very happy. This class will continue till the God will. Okay.
Yes, tomorrow is the last class.
Who said this? I have never done this. Sheikh, I have never done it, because I know that you are taking interest. And if you really cherish knowledge, this is what makes me happy, to be honest. Okay.
So we want you to.
But why are you fighting? Okay.
Yeah, we usually speak about 90-degree, 180-degree. For ISO per liter, there's 45 and 175. What is
I
this?
said that,
How can
to be honest, at this stage, just don't confuse yourself for 45 degree. Think of 45 somewhere in between. We understand that. But neither it is on X-ray plane, the detector can see that. It's quick and dirty experiments which we perform. We do it for some other purposes to save time. Don't worry about that.
So, the two splitting.
Not two splitting, it could be 100 splitting. 1,000 splitting, because magnetic homogeneity is not necessarily only two. It could be thousands, but it's just refocus. Because all slower moving was slow and all faster moving was just merge again.
So, is it imaginary or?
No, it's not imaginary, it's real.
It's real. So
Yeah, because magnet is real. And homogeneity is real. Spin is real. The effect of imperfection of magnetic field on spin is real. Because of that, Larmor frequency difference would also be real. This coherent signal, good signal, would also dephase because various region of the NMR tube is experiencing various magnetic field. But you have the capacity of refocusing. Okay. You can complete your question if you wish to. Okay, so chemical shift, right? On X-ray plane, if there are three signals, now you forgot magnetic homogeneity because you know how to correct it, right? So you now know you're focusing on the chemical shift difference, the real, honest, genuine, interested difference, which is of your interest. You are interested, you have interest in chemical shift, right? All magnetic homogeneity, you can correct it. T1 you know, because if you don't know T1, you'll not be able to design your experiment. The difference in chemical shift is difference in Larmor frequency, nothing else. The difference in Larmor frequency is because of difference in B effective. The difference in B effective is because of 5 reasons which we have discussed yesterday. Okay, understood? So that we will pass. You know the scale. Proton NMR has scale from 0 to 10. C13 has the scale from 0 to 200 and 210 or something like this. There is no apparent relationship, but there is some similarities. High field in NMR, upfield in NMR would also come upfield in C13. the downfield in proton NMR will come downfield in C13 also. So let's assume that a methyl is coming at 1, right? And this is 1 to 200 scale. C13, where it will come? 20, yes? If anything is coming at 2 in proton NMR, absolutely. So this correlation is not always linear, but you can get some idea. You understand what I mean? 0 to 10 and 0 to 200. There is some correlation, not definite correlation. There are exceptions also. Upfield, always upfield. No doubt about it. Downfield, always downfield, right? Shielded, always shielded. Deshielded, always deshielded. Chemical shift correlation, not very linear, but some approximation. If a methyl is coming at 1.2 in proton, where you expect that to be in C13? 24 to 25, 26, right? Alas, if anything is coming at 4.2 in proton NMR, if proton NMRs, aromatic protons, are coming at 7 in proton NMR, where? Understood? It's not that linear, but some correlation. Okay? Thank you. I think it's enough today. Though I didn't got the tea and samosa. But no complaint.
Can I take one last question, please?
Sure.
Sir, during the time we were discussing about the eco type of
Spinning.
reagent, my mind was flashing with designing experiment for determining different nuclei. You once talked in the last class. In that case, we were doing the same thing. First, we were providing a 90-degree pulse, and then start, and then we provided 180 degrees. So that was a thing designed to determine. That was a thing designed to determine different nuclei. For example, in the first setup, we were analyzing proton, and in the second setup, when we were providing 180, we were determining carbon-13. So it was flashing in my mind.
No. So as I said that I really appreciate questions. Okay, in this case, what you're actually referring to my passing remarks, which I have not really reached yet, because eventually we'll study that. I was talking about that you can, in one NMR experiment, you can handle 2 nuclei. Okay, and 3 nuclei, 4 nuclei. They do that. Athiya is always doing it. She is a molecular biologist and structural biologist. So she handled proteins, and she handled carbon, deuterium, carbon, proton, and nitrogen. Okay, so she handled all of them. She wanted to know carbon correlation with hydrogen, hydrogen correlation with nitrogen in one experiment, right? So she's playing with 3 different nuclei, but for that she has 3 different radio frequency oscillators, 3 different frequency range. She's playing with 3 different pulses of a very different magnitude, right? Because carbon will not appear, proton will not appear in carbon. Everything 3 different radio frequency oscillators, radio frequency radio will have to be on 3 different. Here we're talking about not that experiment. We're not talking about 2 different nuclei. We're talking about 1 nuclei, that is proton. Okay, so we have nothing to do with it.
How does the instrument know that we are interested in machine?
Because you select. If you select carbon-13 frequency, then instrument will bring carbon to that position. If you don't select that, then you don't worry. Here you're trying to tune Radio Cairo. Okay. Or Sana. Okay. Over there, you're trying to listen to different radios, but two different figures. Okay. Any other question? Thank you very much. Thank you.
Yeah.